Welcome back. Today we're going to keep developing this idea of square rooting, okay? But then we're going to fully develop it into the idea of completing the square. I do want to take a quick moment, however, to review what does this look like from yesterday. So here I want to get the x squared term completely by itself. Okay, so I'm going to add the 60 over, divide by 5, and now that it's alone, this gives me this ability to square root both sides. So I get x equals plus or minus. Now 12 does not have a nice square root. However, if we're searching through those numbers, those perfect squares to see which one breaks it up, this can actually break up into 4 and 3. And again, the reason I would do that is because the square root of 4 is the number 2. So I could write it just like that. That is how I would expect you to write your answer. So again, the two key things, remember the plus or minus, and remember to simplify when possible. On the flip side, for this one, the whole side of the equation is influenced by that square. So I'm going to square root first, because that cancels it off, so I just have x plus 3 here. And then I have plus or minus the square root of 20. Whenever you get something that is not a nice square root, again, your instinct should tell you, I should search to see, is it possible to break that up? And in this case, it is very possible. 20 breaks up into 4 and 5. And the reason I would do that is because the square root of 4 just is the number 2. Then, of course, you still have this x plus 3 that's sitting over there. If I want to solve for x, just subtract that 3 over. Then you still have the plus or minus 2 square roots of 5 sitting there. So again, from the first notes, that's what I'm hoping that you got out of it, okay? Especially this idea over here. This we are about to develop even further, okay? Because I'm going to show you, what if it's not written in that form? What if I have something that looks like this? Okay, can we get those to look like that one from the top right? And I would say yes, we definitely can. Okay, and the reason I say that is because let's see what happens when I factor this. Okay, x squared comes from the x and x. Two things that multiply to 9, add to negative 6. We're looking for that, okay? That's how that thing factors. Now, you may be wondering, because before, whenever we factored, we were interested in having it set equal to 0. This time, it's being set equal to 2. But there's a difference here, okay? The difference is this is 2 of the same thing, okay? This is x minus 3 squared. I got 2 of the same factors. Now that means this is actually something called a perfect square trinomial. The name isn't too terribly important, but the idea of it is. The idea that when you factor it, you get 2 of the same factors. Because getting 2 of the same factors leads to this, leads to this type of solving right there. Okay, so that is how I can finish this problem now. I can finish this problem by simply square rooting both sides. Remember, whenever you square root, you're getting that plus and minus. This time 2 can't be broken down, so I don't have to worry about that. I gave you an easy one for this first time. And then add the 3 over. Just like that. So that is what the solution looks like to that perfect square trinomial. What about this one? This one takes a little bit more to factor because, again, it's a little bit harder when you're dealing with things that aren't just an x squared. But here, if I call this 2x and 2x, to get the 9, I do 3 and 3. Now again, let's just check to make sure this is going to work. Here I have 6x and 6x. Oh, I'm in luck. That does give me the 12x. So this one does factor nicely. And again, the idea is the same as that first one. The idea that this is special because it gives me two of the same factor. Okay, that's very, very important for this completing the square process, that I have two of the same factor that I'm getting. And now I solve it just like I have been. I can square root both sides because that gets rid of that entire square root over here. And then make sure you remember that you're getting a plus or minus 2. Okay? Square root of 4 is the plus or minus 2. Now here, this one, I do want to make sure you understand that when it's written nicely like this is when really you're getting two separate things happening. Okay, that 2x plus 3 is equaling 2, but that 2x plus 3 is also equaling negative 2. Okay, so in this instance, if you ever happen to get nice values there, I would just remember that really this is two separate things happening. And then you can solve them independently. So this one, my x is negative 1/2, and my x is negative 5 halves, okay? The plus or minus really is two separate equations giving you two separate solutions. But when you have something like over here, when you're not writing it as real values anyway, you're leaving it in the radical form, don't worry about writing the two separate equations. Just leave it compacted into one, okay? So what's the key idea here? What am I hoping we get out of this? Well, the idea that if we can factor, or if we can get a perfect square trinomial, we can solve that quadratic. Okay, so that's this whole idea of completing the square, is if I can create a perfect square trinomial, then I can use this process. Now, sometimes we don't start with a perfect square trinomial, okay? So when we don't start with a perfect square trinomial, that means we have to manipulate it, okay? We have to get it to become a perfect square trinomial. So in this instance, we're calling this completing the square, okay? This is our fourth method. So first step when we're doing this, step number one, is I'm going to get the constant on the other side, okay? So for this one, I'm going to move that constant over right away, okay? So, and now, what our goal is. Our goal is there's something I can add here to make that a perfect square trinomial, okay? Now, if I do that, though, I'm going to have to add it to both sides, right? Because I don't want to change my equation. I just want to change the way that it looks, okay? Now, perfect square trinomial, okay? So that means, oh, sorry, I need the squared there. That means I'm getting two of the same thing, okay? So here, if we're thinking about how could I factor this? Well, to get x squared, we know we need x and x. This 4x right there, remember that's coming from these connections, okay? But I need those connections to be exactly the same, okay? Because I'm looking to get two of the same factor. So that 4x, if I want two of the same thing, it's going to have to split itself evenly amongst both of those factors, okay? So splitting itself up like that, because 2x times 2 or plus 2x does give me the 4x. So it splits itself evenly amongst those two factors, okay? And now this is where you have to remember x squared came from there. There's one final thing that we haven't taken into account yet, and that is those right there. That final connection, that is what tells me what I need to add to both sides. That final connection comes from squaring that number, so 2 times 2. Okay, and hopefully you are convinced that x squared plus 4x plus 4 does in fact factor into x plus 2 times x plus 2. Okay, you can check that. And then over here, negative 2 plus 4, that just becomes the number 2. So let's look at what I've done here. What I've done is now I have x plus 2 quantity squared equals 2. Okay, so again, I haven't changed the value of this equation whatsoever. I've just completely changed what it looks like, because now I'm finally able to solve this using the pattern that we did on the first slide. Now I can square root both sides to get x plus 2 equals, you always need your plus or minus, and now to get x by itself, I'm going to subtract 2 over. And that is going to be my final answer. All right, so again, probably really kind of mind-blowing from the get-go. So let's do another example together, okay, to take a look at how this is going to play out. So again, whenever I say complete the square, that first step, I do want you moving that constant over, okay? Get that constant by itself, get it out of the way, because now what we really want to do, we want to see how can I force this to be a perfect square trinomial, okay? What can I add to both sides so this will be able to be factored as a perfect square trinomial? And so again, let's picture what that means. So what that means, this x squared right here, that's coming from x times x, okay? This negative 6x is coming from these two connections right there. But again, to give me two of the same thing, it has to split itself evenly between those two factors, okay? It has to split itself up. And finally, the last piece here, what I actually have to add to both sides to make this work comes from that final connection. Negative 3 times negative 3 will give me 9. And that's ultimately what I have to add to both sides to get this process to work. 11 plus 9 gives me a 27 over there. And so now I've completely rewritten this. X minus 3 squared equals 27. I haven't changed its value whatsoever, but I've completely changed the way that I'm looking at it, okay? I changed the way that it looks because now I can follow the process that I showed you on that first page. So now let's square root both sides. So x minus 3 equals plus or minus square root of 27. Now square root of 27. Now this is one. There actually is a way to break this down, okay? 27 comes from 9 times 3. And again, the reason that I'm using 9 is because the square root of 9 is just the number 3. Then, of course, x minus 3 still equals this. All right, and then, of course, to get x by itself, we're going to just add that over. But then the stuff that was already here is still here. All right, so now let's talk about, there is a particular pattern that I'm hoping that you see here, okay? So let's think about this process when we were going about it, focusing particularly on these numbers right here, okay? And in the grand scheme of things, remember that is your B value, okay? So let's think about what happened to B throughout this process, okay? So what happened is I divided by 2 to get it to go into those factors. So I took B divided by 2, and then the number that I added came from squaring that, okay? Both times then I squared those numbers to give me what I was adding, okay? So there actually is a pattern to this, okay? Every single time you were dividing B in half and then squaring it to find out what you were adding to both sides of the equation. Then that always led to the factor of x plus B split in half or x minus that B split in half. Okay, so if you don't want to have to go through and write this so many times, you could use that pattern that you're adding b over 2 squared to both sides of the equation and then factor from there, okay? That's the what always ends up happening. All right, now, some of the trickier things that can come into play, okay? So first, let's just make sure we understand. So here, the x squared term, when we're doing completing the square like we are, we don't want any values with it, okay? So we're going to have to divide off first any value that is with that x squared term. So when I get something like this, don't be intimidated by it, okay? What I want you to recognize is you can maneuver around these quadratic equations, because remember the first step was this. Get the constant on the opposite side from the x's. So even if it looks a little bit different, you can still do that, right? So here, I want to get my x's together. So I subtract off that, that 10x, and then add that 6 over. Just like that. Now, remember I said we really don't want anything with the x squared. So what I'm going to do is I'm going to divide everything by 2, okay? Because that is going to alleviate, that constant that's with the x squared, that coefficient of the x squared, if you will. Now I'm set up to do my process from here. So remember, what we're searching for is we're searching for what number can I add to both sides that will let that be factored nicely. All right, so let's take a look. Well, as always, that x squared comes from x and x. That minus 5x right there, that has to be split evenly amongst those two factors so they can end up being the same. So half of negative 5 is going to be negative 2.5. Okay, and that's fine. Okay, I know it's not the nicest number, but you can definitely work with it. And then remember that final connection, the final connection right there, 2.5 squared, that is what gives us what we had to add to both sides to get this process to work. Okay, and when I add 3 to that over here, I get 9.25. So what I've got is, want a little bit more space, what I've got is x minus 2.5 squared equals 9.25. Now that I have it written this way, now I can finish my process. I can square root that. And remember that always gives me a plus or minus. And finally, get x by itself, I can add that 2.5 over. And it gives me that. All right, one more example and then we'll call it good. All right, so again, step number 1, get the constant by itself. Okay, so first I'm going to get these x squareds together. So I have negative x squared minus 8x plus 4 equals 0. All right, now the issue that I'm seeing here is that x squared has a negative with it, okay? And we don't necessarily want that. So if the x squared has a negative, I would divide everything by negative 1 to flip the signs of everything right away, because again, the x squared can have no coefficient with it, not even a negative with it, okay? So right away, just divide everything by negative 1, flip the sign of them all, and now you can move that constant over, just like that, okay? So now we're ready for this process, okay? Now we're ready to start figuring out, all right, what can I add to both sides so this thing can factor, okay? So let's take a look at what we can do. So x and x will obviously make that x squared. I've got that connection. This 8x has to split itself up evenly between these two factors, okay? Because we need two of the same thing, so it splits itself up evenly between them. And then finally, that final connection right there, that 4 times 4, that gives me the number that I had to add to both sides to make all of this possible. Okay, so that means I'm going to get a 20 over here. And let's look at what I've got. So what I've got right now is I have x plus 4 squared equaling 20. Now let's run through the process. So now to finish it, I need to square root both sides. And in doing so, remember whenever you square root, you get a plus or minus. And of course, now look at that 20. We've seen this before. That 20 can split up into 4 and 5. because we know the square root of 4 is 2. So now naturally, if I want x by itself, now I subtract the 4, oh, and I'm left with this. Oh, all right, so big day for us here in completing the square. Okay, so again, I know it's a lot to absorb. So take a moment and write your summary for me, okay? Reflect on what we've done, and then come back ready to do your practice work.